So the three types of coordinate systems are Cartesian coordinate system, cylindrical coordinate system and spherical coordinate system. The Cartesian coordinate system is also called as rectangular coordinate system. Here you have three axes. Again, we are considering three dimensions. Three axes you will be having. You have the x-axis, the y-axis and the z-axis. Base vector x represents the direction of the positive x-axis. Base vector y represents the direction of positive y-axis. And base vector z represents the direction of positive z-axis. Okay? Now the axis, or we can take, will be taking this particular cuboid, or what we can tell is that if you understand, if you exactly see this, if you see this box you can see in the shape of a cuboid it is there. Now this here what you see, or here when you actually see this, or if you have to open the box and see, if you have to open the box and see, okay, box and see, let me tell you. If you can see this particular box, this line, you can see the direction of the finger when it goes from here to here. This is your positive x direction. This is your positive y direction, and this will be your positive z direction. This will be a positive x, positive y, and positive z. So you can see that this, the place where the blackboard is there, that's what something called as it has your y-axis and z-axis. It has your y-axis and z-axis. So this is called as YZ plane. This is YZ plane. The floor that I am standing exactly of this particular portion, it has x-axis and y-axis. So it is called as XY plane. Okay, it's called as XY plane. And this side, if I talk about this side, just concentrate on this. This side when I concentrate, it has x-axis and z-axis. Or actually my right side of the wall, okay, my right side. Or if you are sitting in a classroom, the left side, your left wall, the classroom's left side wall, that is your XZ plane. This is XZ plane, this is YZ plane, and this is XY plane. Okay, you have exactly this. Okay, this is your YZ plane, this is your XY plane, and this side, this is your XZ plane. So let's take a cuboid. Let's take a differential volume. This is dx, dy, and dz. So you have actually dv is equal to dx, dy, dz. dv is equal to dx, dy, dz. This is your cuboidal volume. What actually we are taking is that we are taking differential lengths. Differential length. Dx is a differential length, dy is a differential length, and dz is a differential length. You are multiplying all the three differential lengths, hence you get the differential volume of this cuboid. Now, if we talk about the differential length, the total differential length, let's talk about the total differential length. So that will be d vector L is equal to dx base vector x plus dy base vector y plus dz base vector z. Base vector z. Now you have another particular thing, or you have exactly the each volume contains surface areas. So when we talk about the individual surface areas, let's say you are talking about this surface area, okay. So you have exactly, when you are talking about that particular surface area, Now you have the differential surface areas. When you talk about the differential surface areas, let's talk about this surface area. You can see the bowl where it is there. This has the y-axis and the z-axis. So you have dy dz, dy into dz, dy into dz. I am talking about this. Okay, I am talking about this dy dz, and that surface area is normal to x direction. Means this is the x-axis. This is the x-axis. So the x-axis is perpendicular to this surface area. Dy into dz, the x-axis. You can see this is the x-axis. You can see the direction. You can see the direction of the chalk. This is the x-axis. The x-axis perpendicular. X-axis is perpendicular to the surface area. Hence, d vector sx is equal to dy into dz into base vector x, because base vector x represents the direction. That surface area is normal to, again as I told you earlier, here normal means perpendicular to. The surface area is perpendicular to the x direction. Hence, d vector sx is equal to dy into dz into base vector x. Similarly, if I talk about the left side, my right side of the wall, or your left side of the wall particular, or the left wall, this particular wall, your wall exactly, if I talk about this particular wall, if I talk about, okay, here I can say that, or here I can take the example, okay, let's say exactly, you have this concentric, something is written over here, right, concentric on that particular wall. So it has x-axis, it has y-axis. So dx, sorry, it has x-axis and it has z-axis. Dx into dz, or dz into dx into base vector y, because y-axis, the y-axis is perpendicular to the left wall. Y-axis is perpendicular to this wall exactly, or this particular place, this particular place, y-axis is perpendicular to this. Hence, dz into dy into base vector, so dz into dx into base vector, dz into dx into base vector y, dz into dx into base vector y, that is d vector sy. Similarly, you have d vector sz, that is, if I consider the wall where I am, the particular surface or the plane where I am standing, that has dx and dy. This is dy, this is dx. The wall is perpendicular to the z direction, to the z axis. Hence, dx into dy into base vector z, that is d vector sz. Let me tell you, whenever you are considering the Cartesian coordinate, you have to imagine three planes. Three planes you have to imagine. One is the side wall, as I am the person who is teaching you, my right side wall, or if you are sitting your left side wall. You will be viewing the the video. So the left side of your wall. That wall is nothing but one of these three. Which one exactly? It is dx into dz. Dx into dz into base vector y. That wall is nothing but, you have to understand, this is your left wall. This is your left wall. Okay? Left wall is this. D vector sy. Similarly, d vector sx is the wall of the blackboard. This blackboard. dy into dz into base vector x, because the x, it is perpendicular to the x axis, and d vector sz is your floor. The blackboard wall, the left wall, again I am talking about you actually, left wall and the floor. For the blackboard, it is perpendicular to the x axis, hence base vector x. The left wall is perpendicular to the y axis. Okay? And the floor is perpendicular to the z axis. The floor is perpendicular to the z axis. Hence you have this. So, let me again tell you, Cartesian coordinate system, you have three axes, x axis, y axis and z axis. Base vector x represents the positive direction of the x-axis, base vector y represents the positive direction of the y-axis, and base vector z represents the positive direction of the z-axis. If you take a differential surface or a differential your cuboid with just differential lengths, dx, dy and dz respectively, like the total differential volume will be dx into dy into dz. When you have the differential and d vector L is equal to dx base vector x plus dy base vector y plus dz base vector z. That is direction, or when you take any particular point, you take any particular point in this particular cuboid, it will represent its length or its particular position. Or you can take, when you take any particular length between 2 points, you can talk about the position everywhere. Now, when you talk about the surface areas, you have 3 surface areas. One is left side wall, the blackboard and the floor. Left side wall is perpendicular to the y-axis. It is perpendicular to the y-axis. And d vector sy is equal to dz into dx into base vector y. The blackboard, the board, that wall, that plane is perpendicular to the x-axis. It is perpendicular to the x-axis. So dy into dz into base vector x, that is d vector sx. Now, the floor exactly is perpendicular to the z-axis. Hence, dx into dy into base vector z. Okay, so d vector z. This is the Cartesian coordinate system.